Exercise 7. Have you had a graph of f of x equals to 15 minus x squared? The following diagram shows part of the graph and the rectangle OABC, and so on, blah, 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 blah. Find the coordinate of A that gives the maximum area of the rectangle OABC. And the point is here that we could, if A is here, we get this rectangle. If A is supposed to be here, just know that A is on the negative x-axis, and then the rectangle will look something like this. If A is over here, then it will look something like this. And the question is, where should we put A if we want the area of the rectangle to be as large as possible? And the first thing we have to do is to find a function which can give us the area of this rectangle. And then you should start with putting up the formula for the area of a rectangle, which is width times height, and the width here is equal to the x coordinate of A. If A is here on -2, or we can look at this is the absolute value of the x coordinate, right? For A, if A is on -2 here, we know that the width there is 2. If A is on -3, the width, I can't say that, sorry, this something is 3, like this. So this is, I just put this equals to x, okay, because it would be the same if I did it on this side. It's symmetric, right? So if A is here or here, that doesn't matter where A is, if it's positive or negative. So I just put this width as the x coordinate of A, the point A, call it x. And the height is the y coordinate for the point B, or if you put it on this side and let B be here, it's the y coordinate of this point B. And the y coordinate of a function is the thing I'm gonna get if I put the x coordinate into the function. The x coordinate to A is the same as the x coordinate to B, so this is actually f of x. So this is 15 minus x squared. We can also think that the height is restricted by the function. It's the function who decides the height of this rectangle, right? No matter how I draw it, the height is the function value. So then we can find the area of this triangle. It's the width, which is x, times the height, which is 15 minus x squared. So we get that A of x, we can write now, is 15x minus x to the power of 3. So this we call the area function. This is a function which gives us the area of this rectangle. And we want to maximize this area, this function, so we have to find the maximum point of this function here. So then we have to take the derivative and put the derivative equals to 0, and we will then get an x value, and here we probably will get 2 x values here, and you have to use the negative one since A is on the negative side on the x-axis like this. So yeah, so find the derivative and put it equal to 0. I hope that made some sense. That was exercise 7.